Hi everyone, I'm Ethan Lamb from Miss Axelson's 2020 Period 2 class, and today I'll be doing an explanation on U-substitution. So here's the essential question. How do you integrate a composite function? And remember that a composite function is a function inside of another function. So as you can see, you cannot use power rule to solve this integral. Alright, here's a quick review. Please pause this video and answer the power rule integral question. If you got 1/3 x cubed plus 3x plus c, then you're correct. You can just separate these and do integration by each part. Like the x squared is, take the integral of that is 1/3 x cubed. Integral of 3 is 3x. Now pause the video and answer this chain rule question. Alright, well if you got 4 times x squared plus 3 to the third power times 2x, you're correct. So what is U-substitution? When learning about U-substitution, you have to remember that differentiation and integration are opposites. So here's an example. We have the derivative of f of x, and that equals f prime of x. But when you take the integral of the derivative of f of x, you get f of x plus c. And if you take the integral of f prime of x, you get integral of f prime of x dx. So essentially, the integral and the derivative cancel each other out. And also, here's the chain rule. The chain rule only works for the derivative. And essentially, if you're given this integral, you have to use the opposite of chain rule. And when you have to integrate something that looks like the product of a function and its derivative, then you have to use U-substitution. So how U-substitution works is that you have a u, and you substitute u in for g of x. So the next step is you take the derivative of both sides, you get du g prime of x dx. And essentially, you will be able to plug the u straight in and the du, and you end up with this. If you plugged in g of x equals u and g prime of x dx equals du. And you will only use this u substitution if you've tried power rule and it did not work. And essentially, u substitution, the goal is to simplify the integral so that you can use power rule. So the key ideas for u substitution is that your goal is to replace all the x's with u's, and you also want to simplify the equation so that you can just use the power rule to solve it. And usually use the innermost function, although sometimes you just choose whatever that best simplifies the equation. So some of the steps are, first you pick a u, and then you differentiate the u, and then you solve for the dx, and then you plug them all back into the equation and just do regular integration. So sometimes you need to solve for the x in terms of u, if there's still x's left in the equation, in the integral. So here's an example of identifying u. So can you tell me what the u and the du are? So please pause the video and write down what you think the u and the du for this equation is. Well, if you said that the u was x squared plus 3 and the du was 2x dx, then you are correct. So essentially, we chose the inner function, which is x squared plus 3, and we designated it as u, and then we took the derivative of both sides, and you got du equals 2x dx. And then afterward, you would solve for dx, and then you would realize that the two x's cancel out, and you would end up with u cubed du. As in, the u replaces the x squared plus 3, and the two x's cancel out. And then you just use the general power rule, and then substitute the u back into the equation, and this is your answer. So here's another example. What is the u? So this is given that the integral of e to the x is also e to the x, and the derivative of e to the x is also e to the x. So what is the u? Please take a moment to pause the video and write down what you think the u is. If you thought the u was 5x plus 2, then you are completely correct. So as in the previous problem, we would just take the derivative of both sides and we'd get and solve for dx. dx equals 1/5 du. And then we plug that back into the equation and plug the u in for the 5x plus 2, and we get this integral. And once we get this integral, we can just use basic integration, pull out the constant multiplier, and then use basic integration and solve that problem. And this is what you would get after you sub u back into the equation. So here's another example, but this time with trigonometry. So please take a moment to pause the video and write down what you think u is. Well, if you thought u was ln of x, you are correct. Du equals 1 over x dx after you take the derivative of both sides. Solving for dx, you would get dx equals x du, and the x would cancel out with this x, and which would leave you with the goal of sine u du. And after that, you can just simply do basic integration, and you get negative cosine ln of x plus c. So what happens if we have multiple variables? Well, take a moment to pause this video and write down what you think u is for this expression, integral. If you said u was x plus 4, then you would be correct. And after that, same process again. We take the derivative of both sides and then solve for dx. Plug it straight in. But this time we have to do something else. We have to change x in terms of u. And we can do this by rearranging this equation. So u equals x plus 4, we can subtract 4 on both sides and get x equals u minus 4. And plug that straight into the x. And this is what you should get. After you do some arithmetic, you would get this. And then we can do basic integration again. We can split it into we can split this integral into 2. And then do basic integration again. General power rule, and then sub back u into the equation and get this answer. Last example. So in terms of definite integrals, you will have to do something different this time. You will have to sub in the limits of integration into the u equation and then get new limits of integration as seen in this. So given this integral, take a moment to pause the video and write down what you think u is. If you said u was 2x minus 1, you are correct. So essentially you would just do the same process again. Just take the derivative of both sides, solve for dx, dx equals 1/2 du, plug it straight in. And now you know you will also have this x left over, and you would have to rearrange this u equals 2x minus 1 equation into x equals u plus 1 over 2 equation. And you would plug that u plus 1 over 2 into the x. But this time we have to do something different, as said, about the limits of integration. Since you changed all these x's into u's, you would have to change the limits of integration as well. So you would have to plug the 9 and the 1, the 5 and the 1 into the u equals 2x minus 1 equation. And you get u equals 9. And if you plug the 1 into the equation, you get 1. And those are your new limits of integration, 9 and 1. Pull out the constant multiplier, and then just do basic integration after that. Boom. And then do arithmetic, multiplication, and you get 16 over 3. Thanks for watching my video. I hope you understand U-substitution better now. Good luck in your calculus class!